Hello guys, you're welcome back to my channel, Fun with Physics. In this lesson, we are going to look at the types of circuits. That means at the end of the lesson, you should be able to tell the difference between the different types of circuits. That is the difference between the series and parallel circuits. Okay, so as a starter, how do charge move? Let's say you're provided with a battery, a wire, a lamp, and you ask to connect it, and you actually do the right connection. So how do you think that charge flew through the whole system back to the battery? If you have an idea, guys, comment on the comment section of what you feel. Okay, now charge basically flow if they have enough energy. Okay, so if they have enough energy, which of course the battery, that's the function of the battery, to supply enough energy to it, what the flow, that means charge will flow from the region where they have much energy to the region where they have less energy. Okay, anyway, as the lesson goes on, you move on, you're going to get to understand this better. This potential energy is actually called the voltage. All right, and the voltage is stored in cells or battery. That means without the battery or without the cell, there will be no energy or voltage, as the case may be. The types of circuits. Now, if you look at the arrangement, the one you have on the left-hand side and the one you have on the right-hand side, you discover that that's a slight difference. Okay, for the left-hand side, it has a single loop, just one wire, and the components are connected end to end. Did you notice it? A single loop, one wire here at this end, the other wire from this end to this end, and so on. Okay, back to the battery. But this one has like a branched loop. Okay, sometimes more than one loop, okay, or more than one branch of wire. So in this case, we have two branches. We have this one and this one. This kind of arrangement here is called a parallel arrangement, while the previous one, the one on the left hand, is called a series arrangement. So for a parallel arrangement, the components are actually kept side by side. Did you notice that? Notice that if I draw a straight line, it's parallel to each other. It has more than one branch connected to the circuit. Now, if you are to draw this, it's simple, just similar to what we have drawn before. Lamp, another lamp, all connected to the cell. But in this case, your connection has to also, your circuit diagram has to also branch into two parts, okay, with your lamp, which will combine here, just exactly what you see here. But this time around, you're drawing it with symbols back to this, to the cell. Now, a series circuit components are said to be connected in a series if the same electricity passes through each of them in turn, and the circuit has a single loop. I've said that before. Now, if you have 3 amps flowing from the positive side by the conventional way, the same current is going to flow through each of the circuit components and back to the cell. Okay, the same current. So this kind of arrangement is simply a series arrangement. The cell and 2 lamps are in series with each other, so the same electricity passes through them, all at the same time, passes through all of them. Okay, now in a series circuit, the current flowed through one continuous pathway. Okay, that means like a pipe. You have a single pipe connected to different items. So it means the current will flow through that pipe round back to the channel, the pump. Okay, so similar to this, the current will flow from the battery through a single pathway down back to the battery. It means if I'm to measure the current flowing, all I need to do is to connect my ammeter in that same pathway. Now the current is the same in each point because the current is flowing through the same point, so the same pathway, so the current flowing is the same. So if I'm to connect an ammeter here, or I connect an ammeter here, or even here, I'll have the same reading, the same current value. Okay, like in this case, I have 1 amp flowing through the circuit and 1 amp measured at different points. What is conventional current? Guys, we are familiar with the fact that charges move from the negative to the positive because of course they are negative. But by convention, charges are described to move from the positive to the negative. Before the discovery of electrons, scientists assumed that current was due to the positive charge particles moving from a positive terminal around the circuit to the negative terminal. This way of representing the direction of current is actually called conventional current. Okay, that is what scientists used to think or thought of before they actually had the proper idea. So that same idea has been adopted and is still in use, so we call it the conventional idea, okay, or the conventional current idea, or the conventional current part. It is now known that the charge is carried by electrons flowing from the negative terminal to the positive terminal. Okay, this is called the electron flow. But then, for the sake of this lesson, all of these lessons, we are going to maintain the conventional current pattern. Are we good? Today, both the conventional current and electron flow can be used to represent the direction of the current. Now, look at what is happening on the screen. Did you notice that the charge moved from the positive to the lamp to the negative? This pattern of movement is actually what we call the conventional current. All right. Now, electron actually flow in the reverse direction. You know, electron has negative charge, so it will tend to move towards the positive side. So this method is actually the electron flow pattern. But for the sake of our lesson, we are going to stick to one, which is a conventional pattern. Guys, let's briefly look at this, the conventional pattern. What did you notice? Positive to negative. How about the electron flow? What did you notice? From the negative, of course, to the positive side of the battery. Now, for parallel circuits, we described series and parallel circuits earlier. Now, we want to actually look at it critically. Series circuit has a single loop, but parallel circuit has more than one loop. Now, this is a parallel circuit because it has one loop, two loops, all connected from the cell, or branched loops. A single loop that is branched into two. They are all parallel. Now, notice that the bulbs are arranged side by side to each other. So you can easily draw the circuit components just exactly what you have here or what you have here. So make sure the bulbs are side by side, and we have two switches to control each of the bulb. Okay, in physics we usually draw a parallel circuit like this. So it's a simple way you can draw it. Now, current in parallel circuit, the total current through the whole circuit is the sum of the current through the separate component. It means that if you have 5 amps flowing, once you get to this point, The 5 amp is going to branch out into two parts, just like your pipe, water flow in your pipe. And then you have the pipe is branched. What happens to the water? Of course, it's also going to be branched. 3 amps get to flow to the bulb, while 2 amps get to flow to the resistor here. Okay, so at the end of the day, they combine and then come out as 5 amps back to the negative side of the battery. Okay, is that clear? Now notice that they are branched. That means the sum of the two will give us the total current flow in the circuit. Current in the parallel circuit. In a parallel circuit, the current divides at the point where the circuit branches and then recombines to complete the circuit. We've demonstrated that earlier. Like you have your 2 amps here. When you get to this point, since you have similar components here, 2 similar lamps, it branches into 2 equal parts, 1 amps and 1 amps, only for it to come back as 2 amps one more time in this point. Okay, it's like combining 2 pipes that links together as one. I hope you understand that you got the idea. Now calculate the current measured by the ammeter A1, A2 and A3 in the circuit. Now since we have 2 different components, we don't expect the same current to flow. Here we have 2 amps. Of course, in the other one, the resistor, we will have A2, we will have 4 amps. And then A3, the 2 amps and the 4 amps will combine to give us 6 amps. Is that clear? Alright guys, I hope everything is clear and you perfectly understood the 2 connections, 2 different types of circuits, the parallel and the series. In case you have any doubts, please comment on the comment section below, and don't forget to like and subscribe to the channel for more videos like this. Thank you.